2.8, two variable inequalities. Last section here in chapter 2, and we get into, again, going back to some graphing and looking at these problems. There's some very, very important things that we have to remember about graphing these linear inequalities. And we don't just graph the line. We now need to shade and above or below the line, or use a solid and dotted line. So I'll kind of explain this as I go, but it's all based on what symbol we have when y is by itself. So as you can see, the first example, I've got y by itself, okay? And it's in slope-intercept form. So I need to look, and there's 4 things you have to be able to decipher based on the symbol. First of all, you got to tell what that symbol is. Is it a greater than or equal to, less than or equal to? Okay, so this symbol right here is a greater than symbol. So I know that whenever I graph this line, I'm going to shade above it, because greater than or equal to, I shade above. Less than or below, less than or equal to, I shade below. If it's a greater than or equal to, or a less than or equal to, I will use a solid line, a normal line like we did earlier in this chapter. And if it's just a less than symbol or just a greater than symbol, I'm going to use a dotted line. And that dotted line signifies that no point on that line is part of the solution. So how would I graph this line that is in slope-intercept form? Okay, well, what is the y-intercept? My starting point, or the y-intercept, is -1. So I would go down 1. From that point, I'm going to use my rise over run, or my slope. So again, that's 3 over 1. So I would go up 1, up 2, up 3, right 1. Up 1, up 2, up 3, right 1. So this is my line. If this was a normal line, I would just connect the dots here and draw a nice, very straight line. But because it's a greater than symbol, I have to look over here and ask myself, is it a solid or dotted line? Greater than, greater than. I'm going to use a dotted line. Okay, so again, what does that dotted line signify? It signifies that if I were to plug in any ordered pair, it would not make this inequality true. And then because it's a greater than, I'm going to shade above the line. And what am I shading? I'm shading every possible solution that would make this inequality true. Okay, so I graph it just like I would a normal line. I just have 4 things that I have to make sure that I pay attention to based on the inequality symbol. Okay, so let's look at another example. Again, same exact line here. Okay, where's my y-intercept? I've got a y-intercept at -1. So that's my starting point, and my slope from that point, is up 3, right 1. Up 3, right 1. Now let's take a look at this line. Is this line going to be solid or dotted? Because it's a less than or equal to, it will be a solid line. Okay, so just like I normally would graph a regular old line, and then now it's a less than or equal to, so I would shade everything below. So now, couple points for this line. The line is solid, meaning any ordered pair I chose on this line, if I plugged in that y value and x value, it would make this inequality true. Also, any area that's shaded would make this inequality symbol true. Okay, so let's take a look at one that, again, is pretty simple, but there's a little bit of a difference here. So how do I graph x is greater than or equal to 1? This is a vertical line, okay? So this is a vertical line. I would go right 1, and it's a solid line. Now here's where we have to use a little bit of math common sense. Okay, I can't shade above or below a vertical line, but where are the x values greater than 1? And that would be everything to the right of it. So this is the only time I want you to say right or left, is when you have a vertical line. Okay, otherwise it's always above or below. So if I gave you the equation y is less than -3, I would know that that's a horizontal line at -3. It's a dotted line. Why is it dotted? Because it's just less than, and I would shade everything below. So the graph would look something like that. Okay, so there's 4 examples of that, kind of quick. This is a problem from Desmos where it's not in slope-intercept form. So I have to take x minus 2y is less than 2. And before I can say dotted line, shade above or below, I have to get y by itself. So I'm going to subtract x here. -2y is less than -x plus 2. I'm going to divide everything by -2. I'm dividing by a negative, and I have an inequality. So that symbol flips. Okay, 1 over 2x minus 1. Again, look at your signs. What's the number front here? A 1. You've got to make sure my sign flips because I divided by a negative. So okay, so right here, this less than became a greater than. So now you could tell me that it's going to shade above, okay, and you're going to use a dotted line. So my y-intercept is -1. I would go up 1, right 2, up 1, right 2, up 1, right 2, and I'm going to use a dotted line, and I would shade everything above. And I think on Desmos, when you shade, you just kind of click and it shades for you. Okay. And again, what does that show you? All these ordered pairs down here are in the shaded region would work. Would a point on the line, though, it would not make the inequality true. All right, so let's go the other way. You're going to be given a graph, okay? You're going to be given a graph. Actually, I'm going to change this. This is going to be just a line, not an absolute value. So this is going to be shaded. Okay, so here's the line that we're given. This is all shaded. Wrong example. Let's see here. Okay, so this is just a linear equation. It's got the line here that's dotted. There we go. Okay, so I need to be able to write the equation of this line. What two things do I need to write an equation of a line? I need to be able to find the y-intercept, okay, which is where the graph crosses the x-axis. So my y-intercept would be b equals +1, and I need the slope. Okay, I need my rise over run. So I've got to pick 2 points where I can go from one point to the next. I go up 1, I go left 1. So my rise over run would be up 1, left 1, which is a -1. So to write this equation of a line, I would normally write y equals -x plus 1. But because it's a dotted line and I shade above, because it's dotted, it's going to be a greater than or less than. And because I shade above, it's going to be a greater than. So the equation for this line would be y is greater than -x plus 1. Again, why is it greater than? Because it's a dotted line and I shade above. That tells me from that very first slide that it is a greater than symbol. Okay. Then there's a couple problems here that are called piecewise functions. These piecewise functions go back to evaluating. I've got 2 examples here. You're going to have 2 problems on Delta Math, and they look like this. So you're going to be given a problem. Okay. There are 2 rules here. There are 2 different pieces of this function. The first one, my y value is -4 for any value of x that's not equal to -3. So these are kind of the rules. They're telling you this can not be -3 for x. If it's anything else, I would plug it into this equation, and that would be my answer. So the answer would be -3 if I plug in -3. So this f of -2 is telling me to plug in -2. Well, there is no x to plug in. Where does this -2 fit in the domain? Is -2 not equal to -3? And that answer to that is yes. So I would choose this top equation, okay? And very simply, there's nothing to plug in, so the answer is -4. And again, that's the ordered pair. X is -2, y is -4. Okay, let's take a look at this next example. So again, this is kind of telling me, hey, I need to find which one of my domain rules allows 0. So for this has 3 different pieces in this piecewise function. My answer for the first piece would be 6 if x is less than or equal to -4. So if I were to find f of -5, the answer would just be 6. But I've got to look. It's asking me to plug in 0. Is 0 less than or equal to -4? No. So I can completely ignore the first piece. In the second piece, okay, I would plug it into -3x minus 6 if x is between -4 and 0. Okay, is 0 included in this? No. It says x has to be less than 0, and 0 is not less than 0, so I wouldn't plug it in here. Okay, now my last piece, piece 3, is f of x equals -x minus 4. Okay, is x greater than or equal to 0? Well, yes, I'm asking you to plug in 0, so I would plug in -0 minus 4. Again, where did this 0 come from? It's what I'm asking you to plug in, okay, which is just -4. So the answer to this equation is -4. Okay, well, what if I asked you to plug in, what if I asked you to plug in x equals or f of -2? If I asked you to plug in -2, again, I got to go back to my domains. Is -2 less than or equal to -4? No. So it's not the first piece. Is -2 between -4 and 0? Yes. So I would choose this equation. Okay, -3. What am I asking you to plug in? A -2 minus 6. And then I would just do the math. It'd be 6 minus 6, and I would get 0, and that would be my answer. So again, piecewise functions, when you have this, it's kind of looking at the domain and it's asking you, okay, which one of these domains does it fit in? Again, if I gave you f of -5, I would choose this piece right here because -5 is less than -4, and my answer would just be 6.